Welcome back. So already in the last session we have discussed the working of a four-stroke engine. Now in this part we will be going to discuss the working of a two-stroke engine and how it is different from a four-stroke engine. So that is the objective of this session. So before going to the working, let's discuss the parts of a two-stroke engine. So this is a figure of two-stroke engine, and most important thing is the two-stroke engine completes its working cycle in two strokes of the piston. That means one upward stroke, one downward stroke, it will be completing the one cycle. So we have already seen four-stroke engine completes one cycle in four strokes of the piston. Four movements are required, but here you can see the cycle is completed within two strokes of the piston. So one upward movement and one downward movement is enough for completing one cycle. Now what is the difference here? You have identified looking at this figure. We have already studied the figure of a four-stroke engine. So what is the difference you can identify? The important thing is there is no valves. You can see here at the cylinder head there was an inlet valve and exhaust valve here and here in four-stroke engine, but in this one that is completely absent. So valves are absent in a two-stroke engine. So that means there will be no cam or camshaft that for controlling the movement of valve, that's also absent. So valves and other controlling mechanism for valves are completely absent in a two-stroke engine. And instead of that we have three ports located at the cylinder block. So this is a cylinder block, this is a cylinder head. So you can see here three ports are there. This is the intake port. So port means it's just an opening. This is an opening on the end of the inlet manifold. So you can see here this is the intake port or inlet port, and this is the exhaust port. And other than that we have a transfer port which is the opposite side of the intake port and exhaust port. So this is the transfer port. So that is the important thing. In two-stroke engine we have three ports. First one is intake port, this one. Second one is exhaust port, and the opposite to that we have a transfer port. So this is a transfer port, and we know intake port is used for carrying the air-fuel mixture or air into the cylinder, and exhaust port will be used for removing the exhaust out of the cylinder. And the important thing about transfer port is the upper end of transfer port is connected to the cylinder and lower end is connected to the crankcase. So you can see here two ends, one end, the upper end here of the transfer port is connected to the cylinder, the side of the cylinder, and the lower end is here, that is in the crankcase. So this case covering our crank is known as crankcase. So we already have mentioned that. So the transfer port connects this crankcase to the cylinder. So that is the ending of transfer port. And all other things are same. We have a piston here, we have a connecting rod, we have a crank and crankshaft. So all the remaining things are same that of a four-stroke engine. But the thing is, valves, instead of valves we have three ports, and at the cylinder end we have only spark plug or fuel injector. If it's a petrol engine there will be a spark plug, this one, and if it is a fuel injector, it will be a diesel engine. So that is the parts of two-stroke engine. So you have to draw a neat figure of this if the working is asked. Now let's move on to the working of a two-stroke engine. Now let's discuss the working of two-stroke engine with the help of this animation. And the first thing keep in mind is that you might have thought, so four-stroke engine we have four strokes, namely suction, compression, power and exhaust. So you may think that okay, two-stroke engine we will cut down any of these two strokes. Okay, we will cut suction and compression and we will get the power and exhaust, but that is not the case with the two-stroke engine. We are not cutting down any of these strokes. All this will happen. The suction will be there, compression will be there, power will stroke will be there, exhaust stroke also will be there. Then how we are going to complete it in two movements of the piston? That is by simultaneous working. That means you will be combining the suction and compression. So both will take place at the same time. So suction takes place, simultaneously compression can take place, and similarly power and exhaust are completed in one single movement. So like that we are combining these so that we can complete the entire cycle in two movements of the piston. And for that, the important thing is here the working will takes place not only at this combustion chamber, that is above the piston, but below the piston in this crankcase also we will get the some portion of working. So remember, in four-stroke engine we have the working takes place only above the piston, that is here in the combustion chamber only. Suction, compression, power, exhaust, everything happens above the piston in this combustion chamber only. But in two-stroke engine, not only that, other than this combustion chamber, the crankcase also contribute to the working of the engine. So that is the important thing. So let's see how this working takes place. So we have to start from the upward stroke. For better understanding, in this two-stroke engine we will start the working from the upward stroke. So what are the things happening in the movement, upward movement? So what is the first thing happens? See here, first upward movement, which port will be opened first? So here another thing is the opening and closing of port is done by piston itself. So this piston itself opens and closes the port. So if in a particular position it will be closing the port, and in another position it will be opening the port. So the piston itself covers and uncovers the port. That is the important thing. So first, what is the first thing happens in the upward stroke? Yes, the first thing happens is, you can see here it will uncover the inlet port. See here, moving upward, initially it covers the intake port, but then it uncovers the intake port. So the first thing happens is the suction through the intake port. When the piston moves upward, it uncovers the intake port, and the air fuel mixture from outside, from the fuel tank or from where it is, will enter into this crankcase. So that is the first thing happening. Not above the piston but below the piston, the air fuel mixture or air will be entering into the crankcase. So during the upward stroke, the intake port opens, that is the piston uncovers the intake port, and the air fuel mixture will be entering through this intake manifold to crankcase. And simultaneously what will be happening above the piston, while moving upward you can see compression will take place. So if there is already some air fuel mixture or air is there here above the piston, in the upward stroke obviously it will be compressed. So like that the suction and compression takes place in simultaneously. So at the same time the charge above the piston get compressed into clearance volume. The small volume left above top dead center, that is the clearance volume. So you can see here, so compression takes place above the piston. And what will happen at the end of this stroke, the end of this upward stroke, we will provide the spark. Like in this animation you can see at the end of upward stroke, spark is provided if it is a petrol engine. And if it is a diesel engine, we will inject fuel. So at the end of this stroke, spark is provided by the spark plug and fuel is injected by the fuel injector. So that is the upward stroke. So then what will happen to the downward on the downward movement of the piston? So already we have compressed in the upward stroke and we are providing spark or fuel, whatever it is. So combustion takes place. So we will be igniting the air fuel mixture above the piston. So the ignition of air fuel mixture, we know that will result in expansion of this gas and that will push the piston downward. So you can see here. So after completing upward stroke, the ignition takes place. Gas is expanded and it will push the piston downward. So we are getting the power. So in the downward stroke, we will be getting the power which will be delivered through the connecting rod and crankshaft to the outside. So we will convert the piston movement into rotation of the crank with the help of connecting rod and it will be delivered to the outside. So power stroke happens in the downward movement, the expansion of the gas. And what will happen at the end of the downward stroke, we can see here when downward stroke progresses, yes, it will open up the exhaust port. At the end of or at the later stage of downward movement of this piston, you can see here the exhaust port gets opened and the burned gas will be moving through the exhaust port to the outside, to the atmosphere. So the power and exhaust here takes place the single stroke, that is in the downward movement. So while coming downward, piston first uncovers the exhaust port and the burn gas escape out of the exhaust port. And another thing you have to note down that already we have the air fuel mixture entered into the crankcase in the previous stroke, that is in the upward movement. And at the end of this piston also uncovers this upper end of transfer port here. And you can see here the air fuel mixture or air in this crankcase will be entering above the piston. So that is also happen in this downward stroke. At the end of downward stroke, you can see here this transfer port, this upper end gets opened and the air fuel mixture already there in this crankcase will come into the combustion chamber. So that also happens after the end of the stroke. The upper end of transfer port is uncovered by the piston and the air fuel mixture, if it's a petrol engine, the air fuel mixture, or if it's a diesel engine, air only, from the crankcase enters into the combustion chamber through transfer port. So this is the working of two-stroke engine. So we are combining. So in the upward stroke, suction happens, but that is in the crankcase, and simultaneously compression happens above the piston, and we are igniting. Then in the downward motion, we are getting power as well as exhaust happens. And finally, through the transfer port, the mixture in this region enters into the this region above the piston. So that means the entire working will be completed in two movements, one upward movement, one downward movement. So that is the working of a two-stroke engine. So it is little bit difficult to understand this compared to four-stroke engine. But main thing is you have to understand the opening and closing of port by the movement of piston at different locations. And how will you compare four-stroke engine and two-stroke engine? It's an important question. So already first point we know that in four-stroke engine the one working cycle is completed in 4 movements of the piston or 2 revolution of the crankshaft, because 180 of crankshaft rotation corresponds to 1 stroke. So in four-stroke engine one cycle is completed in 2 revolution of the crankshaft. But two-stroke engine not that much required. One cycle is completed in 2 strokes, otherwise 1 revolution of the crankshaft. And which one will be have more power? If we are constructing a four-stroke engine and two-stroke engine of same weight and size, or same weight, which we will get more power? Because it will be two-stroke engine, because in two-stroke engine the power, most important thing is the power stroke. We will get power stroke in 2 strokes or 1 revolution, but for getting a power stroke in four-stroke engine we required 4 strokes, the double that of the two-stroke engine. So theoretically speaking the power is less. So theoretically the power is less in four-stroke engine and it will be double, or theoretically it will be double in two-stroke engine. If you construct the same size engines of a four-stroke and two-stroke engine, in two-stroke engine theoretically it must get a double power of four-stroke engine, but actually it will not be double, but we will get more power in two-stroke engine. But due to some loss and efficiency, lower efficiency, etc., it will not be that much, but still we will get more power in two-stroke engine. At this point also we know the valves are completely there, inlet valve and exhaust valve is there in four-stroke engine, so we require camshaft, etc. But here there is no valves, no valve guiding mechanisms, so only ports are there which we can open and close by piston itself. So no complex valve controlling mechanism is required in two-stroke engine. And another thing is we use a flywheel. Flywheel means a rotating disc for balancing the torque, for getting a non-uniform torque. Because this engine is a highly fluctuating device. We know that is suction stroke, there is no power produced. Compression, there will be no power. But power stroke, we will suddenly get some power. Again exhaust, we will get no power. So like that, there is a non-uniform torque is produced. So to balance that by inertia, we will be using a flywheel. But in four-stroke engine, we require a heavy flywheel. Why heavy flywheel is required? Because power stroke happens only in 4 strokes. So that is highly non-uniform. But in two-stroke engine, we get power stroke in 2 strokes. So the torque is not that much non-uniform. So we will require only a lighter flywheel. So that is another important difference. In two-stroke engine, the flywheel required is lighter, smaller flywheel. But in four-stroke engine, we require a heavy flywheel. And we know size and space required will be more for the same power. So if you want a 1 kilowatt power engine, this four-stroke engine will be somewhat heavier, or size and space will be more for that much power. But for two-stroke engine, this will be smaller. So that is an advantage of two-stroke engine. Size and space, weight, etc. will be less. But what about efficiency? The efficiency will be more in four-stroke engine only. Two-stroke engine efficiency will be less. Why it is less? That is the question. The main thing is in four-stroke engine we have a separate exhaust stroke, and the piston, what is the position of piston in exhaust stroke or the movement of piston in exhaust stroke in four-stroke engine? In four-stroke engine it will be moving upward. Piston is moving from BDC to TDC. So the piston is pushing the burn gas out of the cylinder. But in two-stroke engine there is no separate exhaust stroke, and also the piston is moving downward while exhaust takes place. So it is not pushing the exhaust. So the piston will not help to push the exhaust. The exhaust has to be itself moved to the exhaust port. So efficiency is less due to this reason. So it is incomplete combustion, incomplete exhaust, and there is a chance of mixing of fresh charge with the exhaust. If the exhaust is not that much perfect, what will happen? Some burn gas will remain inside the cylinder and it will mix with the fresh charge coming in the next cycle. So that will affect the combustion of the engine. So the combustion will become incomplete. So this is an important point. Even though this green color one is the advantage of two-stroke engine over the four-stroke engine. That is why I have given a red color here and a green color here. But the main advantage of four-stroke engine is the efficiency is more. Why its efficiency is more? Because two-stroke engine efficiency is less due to this, to incomplete combustion, due to mixing of air with the exhaust gas. All these reasons, its efficiency will be less. And this is the reason, main reason for this point. Scavenging. Scavenging means removal of burn gas out of the cylinder. That problems are less due to separate exhaust stroke. So in four-stroke engine we can almost completely remove the burn gas because of the separate exhaust stroke and help from the piston. But two-stroke engine scavenging problems are more. So that means the two-stroke engine we will be having more exhaust emission, carbon dioxide, carbon monoxide. So all this will be more in, particularly carbon monoxide. The incomplete combustion, the main component which will be coming in the exhaust will be carbon monoxide. So exhaust emissions are more. So that is why we commercially, most of the applied commercial vehicles, automobiles, particularly commercial automobiles nowadays are four-stroke engine. Why we are not using two-stroke engine even though it is having this much advantage? So many advantages are there, which is having less space, less weight, more power we are getting, no valves are required. But even though we have this much advantage, only above of this point, that is incomplete combustion and less efficiency, we are not using that in commercial vehicles. This point is the most important thing. It will have more exhaust emission. So we know that if you want to run an automobile in a road, we require a smoke certificate. For every government is following some emission norms. You know Bharat, what is Bharat Stage 6? Bharat Stage 6 we are following now. Earlier it was Bharat Stage 4. All these emission norms, there are strict regulations about the percentage of carbon monoxide and other exhaust gas. So two-stroke engine will not satisfy with these emission norms due to this incomplete combustion and high exhaust emissions. So that is why we are not using this two-stroke engine in commercial vehicles. But where it is used, we can use it in small scooters. Some of the scooter manufacturers or bike manufacturers are earlier used it, and we can use in lawn mowers, the grass cutting machines, because there is no emission norms, only the size matters. Similarly in aircraft, smaller aircraft, we can use two-stroke engine, because there also the weight is more important, the emission etc. is not that much important. So this is the comparison of four-stroke and two-stroke engine. So you can see more advantage is for two-stroke engine, but due to this only these 2 points, that is efficiency is less and incomplete combustion, we are not using this in any of the commercial vehicles. And finally, how will you distinguish a four-stroke engine and two-stroke engine? See here, you have two vehicles by the same manufacturer, Yamaha. This is Yamaha RX100. This is another Yamaha bike. So one is two-stroke, one is four-stroke. So how will you identify that? By just visually, how will you identify that? The main thing we can help to identify is, we know that there is no valves in two-stroke engine. There is ports only. But four-stroke engine we will have valves. But we will not be getting the view of valve or port externally. And the only thing you have to note down is this silencer or the exhaust. This silencer will be the end of exhaust manifold. So where it is originating, that is the point you have to check. So in two-stroke engine we know that the exhaust port is very much lower side at the cylinder block. So you can see here, this is a cylinder, this is the engine cylinder and cylinder cover. So you can see here the silencer is coming from the lower end of the cylinder head, the cylinder block side. So that is a point you have to check. But this is a four-stroke engine. You can see here, this is a cylinder head, cylinder block, and this silencer is coming from somewhat the upper side of the cylinder. Because here there is no port, valve is there, valve will be at the cylinder head. So this is the cylinder and it will be coming from the upper or the somewhere upper region of the engine cylinder. So that is the points, most relevant point to identify the four-stroke and two-stroke visually. Because you will not have any comparison of power, weight, etc. If it is having different power, it will have different size also. So will not be compared by weight or size. So you have to check the silencer or the position of exhaust manifold with respect to the cylinder. If it comes from the lower end of the cylinder like this, it will be a two-stroke engine. If it comes from the upper region, it will be a four-stroke engine. One point also we can note down is, in four-stroke engine we already told that in the crankcase, because there is no working takes place in the crankcase, we use the crankcase for lubrication oil. So it will act as a storage or sump for the collecting lubrication oil. So lubrication oil is the oil used for reducing friction etc. But in two-stroke engine that is not possible, because this lubrication oil we will not be able to fill like this, because already the working takes place in the crankcase. So we will not use the crankcase for collecting the lubrication oil. So that is another point. In four-stroke engine, the bottom of crankcase act as a storage tank for lubrication oil. But in two-stroke engine this is not possible, because we already know suction takes place in the crankcase initially. So we will not use for collecting the lubrication oil. But instead in two-stroke engine where we will inject or use this lubrication oil, we have to mix it with the fuel before filling, and it will be directly filled in the fuel tank itself. So you might have seen some two-stroke auto rickshaw etc. They will be adding this lubrication oil directly with fuel in the fuel tank. So we will not be able to use the crankcase in two-stroke engine for adding this lubrication oil. So that is another point also you can check for identifying a four-stroke engine or two-stroke engine. So thank you.